Hello everyone. Today we'll be going through an optimization program for a hypothetical swim relay race. So the 400 medley relay is split up into four legs. There is a 100-meter freestyle leg, a 100-meter breaststroke leg, a 100-meter butterfly leg, and a 100-meter backstroke leg. So this is a problem that is frequently found in optimization textbooks. There are four swimmers labeled here, and their projected times for each of the strokes. And the objective here is to find the combination that will lead to the fastest time. So the way that we're going to formulate this problem is by essentially labeling each one of the boxes within the table 1 through 16, and then we're going to have to incorporate some constraints from that. So down here I start to get into how we might structure these constraints. So we want to make sure that only one swimmer swims in the freestyle portion, only one swimmer in the breaststroke portion, one in the butterfly, and one in the backstroke. Additionally, we want to make sure that each swimmer only swims one of the legs. So you can see how we're dividing this table up across the rows now, and we'll eventually set a constraint so that each swimmer only swims in one leg of the 400 medley relay. Okay, so we were able to solve this problem by going into a Jupyter notebook and running an optimization program. You may have seen in some of my previous videos, I have gone through optimization problems with the package Gekko. I really enjoy using this. It operates fairly quickly, and I found that structuring the problems is relatively easy when using this package. So the first thing I've done here is import the medley relay swimming optimization table from the Excel file that was just shown. And again, I have it labeled here how we are going to structure this problem. It took a couple minutes to figure out how this problem should be formulated, and I've realized that there's probably a couple different methods for the formulation of this optimization problem. If you have an idea of how it could be structured more efficiently than what I'm about to show, then please do reach out to me, because I'm curious to see what other methods could be used to solving this problem. So the first thing I've done here is I just initiate the model. And so from here, we're going to create binary variables. So this is an integer program, but what we're going to be creating is an integer program that spits out either zeros or ones. And essentially the zeros and ones are going to represent no's and yeses. So eventually this table here will be populated with zeros and ones, and ones will correlate to which swimmer is swimming which event. So now that we've initiated the variables, we need to set some constraints. The first constraint is making sure that this first swimmer only swims one leg. So you can see that x1 plus x2 plus x3 plus x4 needs to equal 1. And we do that for all of the swimmers to make sure that they're going to only participate in one leg of the race. The next constraint is to make sure that we only pick one swimmer to swim in the freestyle leg. This is just due to the nature of the medley relay, and it just is pretty intuitive why we would do that. And lastly, we just need to put in an objective function, which is to minimize the time it'll take for this team to complete the relay. So what we're doing here is we're saying x1 times the freestyle time for x1, which is the Gary Hall. So this position times this time. And we go and essentially do that for every position. And because at the end, our results will be either zeros or 1, this may turn out to be 0 times that time. And this one might also be 0. This one might be 0, and then this one would be 1 in that case. And then the minimization problem, it cycles through the possibilities, and it'll provide the optimal solution that tells which swimmer should swim a given leg. So I will go back through and run this program, and we will be able to determine which swimmers should swim each leg. Okay, so now we're going to run the optimization. Okay, so the first thing that we see is our optimal solution is 207 seconds. The next thing we see is we want to make sure that there's only a total of 4 ones here, and it looks like that's correct. And we can go back to our constraints and confirm that there's only 1 swimmer selected, and only 1 swimmer selected per event, and to make sure that each swimmer was selected. So we are able to convert this total time in seconds to minutes and seconds, and our optimal solution is a total of 3 minutes and 27 seconds, and the outputs are right here. So we'll have Gary Hall swimming the butterfly, Mark Spitz swims the backstroke, and these last 2 guys fill in the other legs. Breaststroke. Okay, so you can see how we were able to formulate this problem and use the Gekko package to optimize our lineup for this event. And this was just I guess a hypothetical problem found in a textbook, but it was interesting to see that after getting this output for the medley relay of this group, I was able to check and see, and it turns out that 3 minutes and 27 seconds is pretty close to a world record. So it's cool to see that we were able to optimize that lineup of swimmers to, based on their projections, find an optimal solution. So thank you for watching this video. I would greatly appreciate it if you could subscribe or like this video, and please let me know if you have any questions.